Hello, Sharks. Today we will be presenting you a new invention for a potential prosthetic finger inspired off of a seahorse tail. Here we have the prototype here, and as you can see, this articulation is good for gripping. Unfortunately, this prototype is a little bit broken as one of the joints was defective. However, we do have a video of the prototype working later. To show you the idea behind this prototype is based off of seahorses. We took a paper from Nature, the journal Nature, analyzing the mechanics of the seahorse tail. As you can see, the seahorse is a very bony fish made up of a lot of bony plates, and the tail is made out of these sections of 4 bony plates connected via the vertebra all the way down. And the way that they are organized and the way that they are laid out allow them to not only be very flexible and bend in many degrees of freedom, but also resist compressive forces very well. This paper found that in comparison to a circular cross-section, the square cross-section of the seahorse tail actually not only was better for gripability and control of the seahorse's grip, but also against compressive forces as well. Here, in this paper, they were whacking their mimic prototypes with rubber hammers and finding that the square cross-section was much stronger than the regular circular cross-section that you might find in most organisms. So what we did was we decided to emulate this design, be inspired by the seahorse, and try to make a prototype of a prosthetic that would be much stronger to compressive and torsional forces than a traditional prosthetic finger. Here is some of the CAD that we did. The profile of the entire finger, which you can see here as replicated here. The outlined in blue is our mimicry of the plates, the bony plates of the seahorse. In green is the vertebral structure, which we printed out of a soft rubberized polymer called NinjaFlex. And in the pink, various joints in order to create a more human-like finger bending motion for better pinching. The main structure is made up out of these plates, creating the main structure of the finger. These plates are only connected to the soft core or the vertebra via the T-shaped connector here. They are otherwise free-floating and sliding against each other and connected to each other in these pin and ball joints that you can see outlined here. This is a cross-section of our finger and as sort of the front view of its articulation. And you can see how those are connected. They're connected to the vertebra and then sliding up against each other. We did a whole analysis of both the paper, the results, and the analogy between our proposed design and the original inspiration source, the seahorse, and found that these two were similar enough in our various components as well as the performance criteria that we believe this is a good example of bioinspiration. And finally, here is the video of the prosthetic working and as it's fully intended to. As you can see, the prosthetic can be actuated using fishing line and rubber bands to create a passive bending back. It is strong enough in order to pinch against the pseudo thumb and actually hold and grip objects. And most importantly, it is actually very strong. Here you can see us trying to grip the thing. Obviously, this prototype needs some work in the actuation department in order to create a stronger grip. However, what's most important is this is a very strong finger. even to very, very strong forces enough to knock it off of its mount, the finger itself will not compress or break. Thank you very much for listening, and I hope you have a good day.